In the mechanics lecture 1, we have gone through energy conservation. Now in this lecture 2, they will study a very important concept. That's concept of time. What is time? What do we mean when we say that time is 6:32? So we want to say that it's 6 hours and 32 minutes. But then what are 6 hours and 32 minutes? 6 hours means after the last reference point, that is 12 o'clock, the clock has made the minutes needle has made 6 full revolutions. So after each revolution, full revolution, that is 60 minutes, 1 hour has passed. So 6 hours has passed, and after 6 hours have passed, the second revolution, the second needle has made 32 revolutions. So 32 minutes. So this is what we mean. It means that we are defining time with the help of some periodic event. That periodic event can be rotation of second needle or minute needle or hour needle in our clock, or basically it has started from rotation of earth on its own axis, or total revolution of earth round the sun, that is 1 year. So every time we have defined time by some periodic event. That's the meaning of time. So what is time? No good definition of time exists as on today I am telling you. Webster Dictionary defines a time as a period and a period as a time. So circular definition. Nothing comes out of it. Another definition says time is what happens when nothing else happens. Okay, applicable in normal situations. But there's a problem with this definition. What happens that if someone is traveling at a speed near the speed of light, time becomes standstill for him. And so even time does not happen for someone traveling at the speed of light. As it happens in Einstein's paradox, which also have been shown beautifully in the movie Interstellar, a Hollywood movie. Recently it has come, if you have seen it. So what Einstein's twin paradox is, that suppose if there are two twin brothers, and one brother stays on earth and another brother takes a spaceship and moves beyond the earth with the speed nearing to light, and suppose the moving brother goes and goes and goes on for 10 years and then comes back after 10 years. So it total takes 20 years. So after 20 years, if when he started the journey, if both the brothers, they are twins of same age, so if both the brothers are of 20 years, and then one brother has made this journey and returned back after 20 years, so when he will return back, his twin brother, who was originally at 20 years, will now be of 40 years. While this man who took this journey, his age will be 20 years plus some hours, you can see. This much difference will happen if he has really traveled a speed nearing to light. So at one end we are saying that time happens when nothing happens, and at the another end, when something great is happening, when someone is traveling nearing the speed of light, time is not happening for him. Time has come to stand still. What modern theory says that at any point of time and space we are passing through both time and space, and the speed of our passing through time plus speed of our passing through space is equal to, means addition of both is equal to speed of light. So if we are traveling through space at a speed of light, our passing through time will become 0 and time will come to stand still for us. Mathematically, a speed of our passing through time plus the speed of our passing through space is equal to speed of light. That is 3 into 10 to the power 8 meters per second. And that's why if we are passing through speed of light in the space, then our speed of passing through time becomes 0. So how we measure time? Time is, I have already told you, always expressed in terms of counts of some periodic event, like the count of Earth's round sun, years, on its own axis days, count of clocks, minutes, needles, full revolutions, hours, or second needles, full revolutions, or in calendar, what's happening? That one full month is passing after 31 days or 30 days, then 1 month is passing after 12 months are passing, then 1 year is passing, after 10 years are passing, 1 decade is passing, after 10 decades are passing, 1 century is passing. So it goes on like this. Similarly, in the clock, when minute needles completes 1 full revolution, then hour needle comes from 1 to 2 or 2 to 3. And when the second needle completes its full revolution of the clock, then this minute needle moves from 1 minute to, from 10 minute to 11 minute or something like that. So time is always being measured or expressed in terms of counts of some periodic event. Now what's definition of a second? Modern definition says that 1 second is the time taken by 9 Arabs 19 crores 26 lakhs 31,770 vibrations of the light of a specified wavelength emitted by a cesium-133 atom. So it's being measured as how much time it's taken in these many vibrations by that radiation. And how we measure short times? Well, normal times can be measured with mechanical pendulums or normal clocks. Short times are measured with oscilloscopes, actually in terms of distance on the oscilloscope screen. Usually electron beam oscilloscopes are used, where an electron beam is controlled with vertical and horizontal voltage and made to fall on a phosphor screen, where time gets converted in horizontal distance between the peaks or troughs. So short times up to 10 to the power 15 or 10 to the power 12 second have been measured with calibrated electronic oscilloscopes. Laser helps in building oscilloscopes which can measure shorter times, but their calibration is not yet possible. So in terms of troughs or peaks, we measure time on the oscilloscopes. And very accurate times up to 10 to the minus 12 seconds have been measured. How do we measure shortest times? Again, it's measured in terms of distance only. Suppose if we want to measure lifetime of a pi meson, which travels 10 to the power minus 7 meters in 10 to the power minus 16 seconds and then disintegrates. So what we do? We observe in a microscope the minute tracks, the minute tracks left in a photographic emulsion in which pi meson has been created. Now the definition of actually time here is life of a pi meson in seconds is equal to distance traveled by the pi meson, length of track in meters divided by its speed. So distance in meters per second divided by distance in meters divided by its speed in meters per second. Second goes up, meters cut, and second remains. So that gives the lifetime of the pi meson. So it shows the interdependence of time and distance. Now how do we measure long times? Counting seconds, counting minutes, counting hours, counting days, counting months, counting years in terms of tree rings. As these trees, it's called, they add one ring every year. So by counting the rings when we cut the trees, by counting the how many rings it has on its cutting section, we can know how much years it has survived. Or river bottom segments, every year some flood comes and the river makes one mark on its segment. One segment grows. By counting those segments we can know how many years have passed. Then counting decades and counting centuries. How the centuries are counted? These are counted through radioactive materials as clocks or radiocarbon dating, which we will see now. What is radiocarbon dating? Radioactivity is emission of alpha beta particles or gamma radiation from certain materials called radioactive materials. A new kind of regularity exists in these instead of a periodic event. So here we are counting time not in terms of counts of some periodic event, but with the help of a new regularity. What is this new regularity? Radioactivity of a material decreases by the same fraction for successive equal increases in its age. For example, radioactivity becomes half after a certain fixed interval of time called half-life of a radioactive material. So after each half-life, the radioactivity comes to half. So fortunately, in many cases we know the initial fraction of the radioactive material, that how much of it was originally. Hence, by comparing the radioactivity on today's date, how much fraction is there of the radioactive material in today's date, with that of initial date, we can find the age of a material or an entity containing that material. That technology is called radiocarbon dating. For example, if a piece of wood contained amount A of radioactive material when it was formed, and now it contains amount B of radioactive material, and assuming that the half-life of a radioactive material is capital T, then the age of the object wood T can be calculated by solving the equation 1 by 2 or half to the power small t divided by capital T, that is its age divided by half-life is equal to amount of radioactivity as on today divided by amount of original radioactivity, or proportion of the radioactive material as on today divided by proportion which was originally there. So with this formula we can know the age of any material even if it's many centuries before it was formed. So numericals on this basis we will see in future lectures, but this is the way how long times are measured. Thank you for today. We will start things tomorrow.